Welcome to another video on my Raspberry Pi 1 show you a webcam showing the board and the Raspberry Pi cam, which I haven't activated yet. Last time I constructed the new circuit using an analog to digital converter with an LDR and another LDR from fischertechnik standing by. Now the point is, and I ended with that last time, finding out that I can use the wiringpi library to use SPI serial peripheral interface to access it. Point being that to use this ADC I should use SPI. So I found some information telling me that I have to use some software to actually address the ADC, but also that I had to use this software to actually initiate SPI using wiringpi. So knowing all that, I need to address it, and one thing is setting it up, but also doing it like this. So first of all, SPI channel is one, which is this one, and for this I grab back to the other information, which tells me that there is a C0 and a CE1. Well, how that exactly going to work out, I don't know yet, but let me just get on and see how it all works out. I need a speed, and that speed is apparently the clock speed in hertz. Then, very important, which comes close here, wiring PI setup for GPIO. And the question is, will this work in the same way? The only thing, because I am using wiringpi here for pulse width modulation to address an LED, being this LED. Anyway, we will hopefully see shortly if that all comes true. Then I need wiring PI and then the SPI setup, and that is then SPI channel and SPI speed, and then the most important part is, and I will do that right in the while loop, is to send data. Well, that is according to the example. So it says 42, and let me just do the example. That is typing it in. This sends 2 bytes, being 4 and 2. You can also send 1 byte, and then receive data will be wiringpi, mind where the cursor goes, and then saying wiringpi SPI data read write SPI channel send data. So this should be the whole SPI stuff, but then of course in my case I'm not there yet, because I have still to address the ADC, the analog to digital converter. So that's going to be a second step. Okay, so I've been trying to get Python, working with Python, which seems normal, but the point is that my current code right here and then this part of the code are not exactly exchangeable. In this line you use the string method to send 2 bytes. You want to send a character of 42, you use character CHR instead of string. However, if you look right here, it uses a completely different way of working, and this is about the ADC that I am using. So I think that I should install spidev anyway. So going back here, I do need to start another window. And then let's see, going back here, yeah, I do need spidev. And now the only point is, once again, how do I as quickly as possible load this into my Raspberry Pi? So I can't really download it from this website, well, from this browser, because this browser is running on my laptop. And so let's see. Oh right, here was spidev, which I have to download. So this is giving me a slight problem then. Yeah. Oh wait, I think I did have something alike. Do I still have spidev? No, I do not. I have PI scope, but I do not have that one anymore. So I think to increase my my speed, I should stop this video feed. Now it's going blank, and then start the browser. Because this video feed does take a lot of resources, and Raspberry Pi 1 isn't very much equipped with it. So now let me see spidev. A little bit speed would be nice. And usually look, pi spidev. It says pip spidev, but I'm going, I think, would that work? I can try. Yeah, right. First install pip. No, thank you. So, going here. I think this is not the website that I expected, by the way. Right, let me do this off screen, because this is boring to you. Alright, I have used the time until now to install spidev here, and if you know the command, it's all simple, but well, you have to find out again. Then what did I do here? Commented out everything that was SPI from wiringpi, setting up everything that I showed on that website, and I literally put everything as is, subject to change, of course. Most importantly, these and these. So what do they do? Read ADC, well, ADC being analog digital converter. Then checking if the ADC number is either larger than 7 or smaller than 0. If so, return -1. -1 is a general value used in many programs to return if something is false. Then, if this is not the case, so everything is either equal to from 0 to 7, so 8 values, and it is 8 channels. Then variable R is defined, is assigned SPI transfer to a value, data is etc., and then return data. This is a predefined, well, we predefine this function, def for definition, and here LDR value is read ADC, so here we call this function, and then I hope a nice function is being read. That said, here we are again. So let's see if I hopefully did not screw up the ADC. let's see what happens, because I didn't test it yet. I'm very curious. Right, let's go. Oh, wait. There's a star here, an asterisk, meaning I didn't save it yet. Now I do. LDR value is 0. It's a light didn't expect that to happen, by the way. So what if I... oh wait, I need to do something different. Hold on. No, not this one. This one. Because I want it to be visible in here as well. That's more like it. So what happens if I cover the LDR? It doesn't do a thing. Well, yeah, see the delay, the huge delay that there is now. And I suspect something that this is a matter of that this is a problem, because they say you need to have oh wait, there's something else going on. This wire is loose. Ouch. I better check that out. I had to do some rewiring, because not only they were turned out to be shifted and or stuck in the wrong port, but also these experimental wires are a bit thin and they very easily slide out. So now I switched the wires, orange and white, so now they don't slide out anymore, while everything still works, or supposed to anyway. This works, and right, a little wiring problem now. Yep, it works. Now you see them both working. This one and this one. The only thing is the LDR value is still 0, and I blame that on the value of this resistor, because in the plan it says I really do need a 10k resistor. Can't really quickly find where it stands, but it is mentioned, yeah, right here, a 10k resistor, and unfortunately this is far from 10k. So yes, I really need to replace that, and last time I already was looking for such a resistor and I didn't really find one. Solution maybe to put quite a few resistors in a row in series to add up the resistance. But I have also some potmeters which I may have to use. Anyway, I'll have to find a solution for this, because I want to see if this LDR, if this ADC is actually working. And as soon as the value is something else from 0, I know it's working. If not, the very short connection to 5 volts instead of 3.3 may have been a problem, but I can also check it if that really can hurt the converter. Anyway, time to look for a resistor. For a resistor that is either 10k or close to 10k. I want it working. And another thing is that I'm not quite sure why, but the delay of this video feed is really acting up. Is really increasing. Whenever I have done something, minutes later I still see this going on. So I'm not sure if this is really only dependent on another program running, or that it is caused by it being a network feed and everything has to be sent over the network. I'm not quite sure about it. Anyway, time to find another resistor. So, I rewired, and I still get 0 from LDR value. Now one question was, of course, is the converter broken, overpowered, whatever? And fortunately, this are the data. This is the data sheet of this particular converter with SPI0 interface, as we know by now. And then it says, well, fortunately a single supply operation is between 2.7 volts and 5.5 volts. So this means that the 5 volts from the other SPI power pin, which delivers 5 volt, did not harm. Question: then why is this still happening? Well, of course, answer is for now probably because of this resistor, although I'm not quite sure of that. This is working, no doubt. And I mean the code. Yeah, next is what? Indeed, as I said, finding something that is actually working correctly. But what I find odd is that it just says 0. So, going back to the picture, how about the wiring? Is that really correct? Going here, yeah, I need to be here. let me shift it a bit. So it is about these few pins, 13 down to 10, that need to be somehow in the correct way. So once again, tipping with this pencil, upper side is even, 6, 8, 10, 12, 14, 16, 18, 20, 22. This is 24. And that should wire back to pin 10. And now if I look at, where is it? Well, that is correct. So if this is 24, under is 23, which points to 13, seems to be about right. Next is 21. 21 points to 12 is the fourth. Yes. Next. Fourth. 23, 21, 19. And 19 to be pin 11. Wait. 23, 21, 19 is this one. Yes, that is correct. Then where is this one? Is SHDN, pin 10 to pin 24. That is correct. So now all the SPI wiring is indeed entirely correct. Which leaves the resistor, a 10K one, as I said earlier. So I rewired, and I still get 0 from LDR value. Now one question was, of course, is the converter broken, overpowered, whatever? And fortunately, this are the data. This is the data sheet of this particular converter with SPI0 interface, as we know by now. And then it says, well, fortunately, a single supply operation is between 2.7 volts and 5.5 volts. So this means that the 5 volts from the other SPI power pin, which delivers 5 volt, did not harm. Question: then why is this still happening? Well, of course, answer is for now probably because of this resistor. Although I'm I'm not quite sure of that. This is working, no doubt. And I mean the code. Yeah, next is what? Indeed, as I said, finding something that is actually working correctly. But what I find odd is that it just says 0. So, going back to the picture. How about the wiring? Is that really correct? Going here. Yeah, I need to be here. Let me shift it a bit. So it is about these few pins, 13 down to 10, that need to be somehow in the correct way. So once again, tipping with his pencil, upper side is even, 6, 8, 10, 12, 14, 16, 18, 20, 22. This is 24. And that should wire back to pin 10. And now if I look at, where is it? Well, that is correct. So if this is 24, under is 23, which points to 13. Seems to be about right. Next is 21. 21 points to 12 is the fourth. Yes. Next. Fourth. 23, 21, 19. And 19 to be pin 11. Wait. 23, 21, 19 is this one. Yes, that is correct. Then where is this one? Is SHDN pin 10 to pin 24. That is correct. So now all the SPI wiring is indeed entirely correct. Which leaves the resistor, a 10K one, as I said earlier.